All right, let's just dive right in. You've got all this amazing data flowing into Prometheus, right? But let's be honest, data is just noise until you can ask it the right questions. So, in the next few minutes, we're going to completely transform you from someone who just looks at dashboards into someone who actually builds them. Look, you've got Prometheus collecting metrics. That's step one. But raw data, it's pretty much useless until you can query it. The language that powers every single Grafana dashboard and every Prometheus alert is called PromQL. And trust me, mastering it means you'll be writing queries that find problems way before your customers ever do. So before we can build those really powerful, insightful queries, we've got to start with the fundamentals. It all comes down to two core data types that everything, and I mean everything, is built on top of. Okay, so here's the crucial difference. Think of an instant vector as a snapshot, like taking a photo. It's the most recent single value for a metric, like up. You can graph that, no problem. A range vector, though, that's more like a video clip. It's a whole history of values over a period of time, like up 5m. And here's the key. You can't graph it directly. We'll see why in just a second. You know, the core syntax for PromQL is actually beautifully simple. It really just has three parts. First, you've got your metric name. That's what you're measuring. Second, inside the curly braces, you have your label selectors, which is how you filter things down. And third, that optional time range in the square brackets. Well, that's what turns an instant vector into a range vector. Now, labels, this is where the real power of Prometheus is. This is the secret sauce. They let you slice and dice your data with incredible precision. You can do an exact match, a not equal match, or even bust out regular expressions for some seriously powerful pattern matching to include or exclude whatever you want. This is how you zero in on exactly what you need. And here it is. This is the #1 trap for beginners. If you try to graph a range vector, like up 5m, Prometheus is just going to give you an error. Why? Well, think about it. It has a whole history of data points. It doesn't know how you want to represent all of those as a single line on a graph. The solution is to wrap it in a function, like rate, which crunches that entire history down into a single graphable value. Okay, now that we've got the fundamentals down, we can get to the really fun part, the 5 essential functions that are going to become your go-to toolkit for pretty much everything you want to do. And I'm serious, it's really just 5. You do not need to memorize dozens of functions to be a PromQL pro. If you get a deep understanding of these 5, you can solve something like 90% of your day-to-day monitoring and alerting problems. Let's start with the undisputed champion, the most important function in all of PromQL, rate. If you just query a raw counter like HTTP request total, all you get is a number that goes up and up and up. It's totally meaningless. But the moment you wrap it in rate, it transforms into a beautiful, actionable requests per second metric. This visual right here is the perfect example of the difference between raw data and real insight. Next up, we have increase. Think of it as the cousin of rate. While rate gives you that nice per second average, increase gives you the total raw jump over that time window. It's absolutely perfect for answering questions like, hey, how many total requests did we serve in the last hour? It's great for reports and summaries. So you've calculated the rate, but now your graph has a separate line for every single pod, and it's a mess. That's where sum comes in to save the day. It rolls up all those individual lines into one clean total. But the real magic, the part you're going to love, is the by clause. Sum by status code lets you see request rate broken down by HTTP status, an absolutely crucial view for any web service. And you know what? Once you understand sum, the next few aggregators are a piece of cake. AVG, min, and max work the exact same way. You can use them to find things like the average memory usage, the instance with the minimum available disk space, or the pod with the maximum CPU load. And yep, they all work with that powerful by clause for grouping. Okay, deep breath. Let's tackle the most complex, but maybe the most important function for any user-facing service, histogram_quantile. Don't let it scare you, it's really just a simple 3-step process. First, you tell it the percentile you want, like 0.95 for the 95th percentile. Second, you feed it the rate of a special histogram bucket metric. And the result? It tells you the latency that 95% of your users are experiencing or better. This is how you stop guessing and start measuring the real user experience. Fantastic. You have totally mastered the core functions. Now we can unlock the next level of power by combining different metrics together using operators. This, my friends, is where you start building some truly sophisticated queries. There are basically 3 main types. You've got your arithmetic operators, so you can do math like dividing errors by total requests to get a clean error rate. Then you've got comparison operators, which are perfect for filtering and alerting, like finding services with a request rate over 100. And finally, logical operators let you combine conditions, like finding instances that are up and are actually receiving traffic. Okay, we've covered a lot of theory. Let's make this super practical. I'm about to give you 3 ready-to-use query patterns that you can literally copy and paste right now to solve some of the most common monitoring problems out there. First up, the API error rate. This query is the perfect example of how everything we've learned just clicks together. We take the rate of requests with a 500-level error code using a regex matcher, see? We divide it by the rate of all requests and then multiply by 100 to get a nice percentage. This is one of the most critical SLIs you can possibly monitor. Ever need to find your resource hogs? This pattern is a lifesaver. It uses a function called topk to find, you guessed it, the top 3 results. Inside, we're calculating the CPU usage rate, summing it up by application, and then topk just hands us the busiest 3. This is incredibly useful for capacity planning and troubleshooting. And here it is again, our latency query, but now presented as a complete copy and paste pattern. We're calculating that 95th percentile latency from our histogram buckets. And remember, this is not average latency, which can be super misleading. This is a real measure of your user's actual experience. So let's just take a step back. In just a few minutes, you've gone from simply looking at data to understanding how to query it, shape it, and analyze it. You're not just a consumer anymore. You now have the tools to be a builder. You now get the difference between instant and range vectors. You know the 5 essential functions for counters, totals, aggregation, and, of course, latency. And you know how to combine them to build the exact queries you need to monitor the health of your systems. And we're not going to stop there. We're going to put this into practice immediately. In our very next explainer, we'll take these exact query patterns we just learned and use them to build a complete production-ready dashboard for a real Spring Boot application, right from scratch. So I'm going to leave you with this thought. You have the tools now. Your systems are producing the data as we speak. The only question left is, what dashboard will you build first?